This is my PowerPoint that I use to teach Boolean operators to my students. A Boolean data is data that can really only be represented in two values, and in computer science we're talking about true and false. If you remember from the conditionals PowerPoint, basically each conditional command creates a question in different styles of questions that can either be answered yes or no or true and false. And that allows us to create commands to selectively run different portions of our script based upon the information that is incoming, whether that be from a key press or position of a sprite or really any condition that we have created. The operators portion of this simply increases the complexity and the asking power of the conditional statements by allowing us to look for the inverse of conditions, to be able to look for multiple conditions all at one time. We are entering in heavily into a portion of the programming where it is not so difficult to actually create the statements using the scratch commands, but it's more so the difficulty that students are going to have to understand the logic of what they want the computer program to do and then translate that into some sort of if-then statement or wait statement using the conditions in action. So you're going to see a shift, I think, in the areas that students are going to have difficulties, and it may represent difficulties for any programmer, because once you start to learn the language, you're going to find that now you just have to figure out how to use the language in different contexts to be more precise and accurate with your terms. It's kind of the same thing as that most people can speak English, but it's very hard for people to craft a true story like great authors do. So let's dive in here real quick. So the first part we're going to talk about Boolean operators are the ability for us sometimes in this case to look for more than one condition. There's a piece missing here because we could look for the inverse of conditions and we can add on a bunch, and you'll see that as we go along. So our example of something where we want to look for more than one condition, you can see that the example here, it says if you have finished your homework and you have finished your chores, you may go outside. And what that tells us is just like our conditional statements, we have one condition, but in this case we actually have a second condition. And then we have an action that is related to those conditions. But our Boolean operator is the and there, telling us that both of those conditions must receive a true answer before the action is actually prompted. And so we have three Boolean operators. There are actually more of them, and the three that we're going to focus on today are the and, or, and not. And you can see that they have these three blocks. They are under the operators menu in the tool palette, and you can see that they have these hexagonal shape to them both inside and outside, and one of the things we know is the hexagon shape represents conditions, and so it means that we can stick conditional statements in these areas and then stick these inside the conditional or the condition areas on conditional statements. When you look at the palette and you see all the different operators, you can see that there are three other hexagonal ones, and they're the inequality statements. I mentioned these to students that these are also Boolean logic. The problem is we don't have any use for them at this point because we haven't gone over variables, and there would be no real reason that you would want to compare two numbers that are static in value and don't change. When we get into variables next, we will move right into using those inequality statements. Just so you know, for future reference, you see all these like oval shaped commands. These are called reporter blocks, and you can see that those are going to be a little bit different, and we'll have a future podcast or future PowerPoint that goes over where those go, and they become even more powerful as we move on. So let's take a look. The and idea, I try to put it in a graphic to show in terms of a Venn diagram, as if this were condition 1, and if you were inside condition 1, then you would get a true value. If you were outside condition 1, you would get, or outside the circle, be false for condition 1. Now that false could of course be over here too because it's outside that circle. And then you would have to get a true or false for condition 2. And then if we have two conditions, one residing here and one here, if they're both true, then this whole statement gives true. In computer science, sometimes we think of it as gateways, and so in this case it just means that both conditions must be true. Condition 1 and condition 2 need to be true for the entire statement to be true. If one of them is false, then the whole statement is considered false because both are not true. So by way of example, you can see if I have if touching edge and touching space key, then it would change the size by 10. So both of those conditions would have to be true. And you can see a couple of different uses for those conditional statements there. Then with or is a little bit different, because this idea is if condition 1 is true or condition 2 is true, then the whole statement is true. And you can see the entire Venn diagram is filled out. And so here are some examples, and really they're not necessarily a whole bunch of very useful examples, but you can have the students see how it starts to get layered upon each other. And then we have not. Now, not only tests for a single condition, but it makes sure that it receives a true answer if the condition is not true. So in this case, a false would yield a true. And that seems a little bit weird, except if you think about the question, like if the condition was, is the space key pressed? And so then the question would be, is the space key not being pressed? And true would mean that it's not being pressed. And that does help, and this is going to be very, very useful in some of the programming that they'll do in the future. And so they can see a couple examples here. And then you can actually start combining the different Boolean logic. So for example, if you want touching edge or not touching the key space, you can see you can put a Boolean operator inside another operator. Or this one would say touching edge or these two things at the same time. If you start going here, you have to be aware of how it kind of reads. If you see that this and is together, so the first condition would be, is it touching the edge? Or the second condition would be both of these being pressed. And then here you can see that it is not and not. Okay. Here are some examples that I use with my students to show them. I put the conditional statements here, and I put the 3 Boolean operators here so they can see if they can write some sample code. So this one says the sprite should keep changing colors until the S key is pressed and the T key is pressed. And I ask them, what conditional statement would you want? And they'll see that, hey, I want to repeat until both of those, and then we'll have the next costume. And in this case, this would assume, this threw my students off, this would assume that I have costumes in different colors. This possibly could be a command about changing color. But in this case, I left it as next costume because that was something that we were doing with one of our programs. The sprite should rotate continually when the space key is pressed or when touching the edge. And so I asked my students, what do you want to do? And this could be, you see I have an if, and I have the or statement, space key is pressed, touching the edge, and we have the forever because it says continually. And so when I press it down, it should keep asking this question over and over, and it'll turn in increments of 15 degrees. When the sprite is not touching the edge, it should change colors over and over. When it is touching the edge, it should reset color. And so this time we're going to use an if-then. And we could ask this in one of 2 different ways. This is kind of an interesting one to show to students, because I said if not touching the edge, which is what it says here, then change color. And so if it is, if not touching the edge is actually false, which means it's touching the edge, then it would go over here. Now I could change this around by removing the not, which might make it a little bit simpler, and then say if touching edge, and then this would be in the if-then, and then this would be in the else. And so each one of the ones I'm showing you, there are variations you can use. These are just one example of how you can do it. And then here's another one, the sprite should hide. There are 2 reasons it should hide. First, the sprite should hide if it touches the edge. Second, the sprite should hide if the space bar is pressed and it is touching the color blue. And so I added one in here to see that it was a little bit more complex in the way it is crafted. And then we do have a command, and this is going to come up in the future challenge. We do have a command to test whether a sprite is being clicked. But this is not necessarily as helpful sometimes, because if we want an if-then statement, we don't have any condition inside one of the sensing blocks to tell if a sprite is being clicked. But we can use Boolean operators as a workaround. And a workaround means is that we may not have a command exactly for that, but we can recreate the same exact conditions that are going to help us determine whether something's been clicked. And so the question I ask them are, what are the 2 conditions we have for something a sprite to be clicked. And there's really two of them. The first one is the mouse cursor has to be touching the sprite itself, because it's got to be over the sprite for the sprite to be clicked. And the second condition is that the mouse button needs to be pressed down. We actually have sensing blocks for both of those. And so we could say when touching mouse pointer and mouse down, which is a question about whether the mouse has been clicked. Now, interestingly enough, and this may go a little bit beyond what you need to know at this point, but a mouse click in this case would be getting the cursor over the sprite, pressing the mouse button down, and then releasing the mouse button. That would be the click. Right now, this is a click and hold in the beginning because it wouldn't actually test to see if it is not clicked. So sometimes you can actually add after this. You can add, hey, if it's touching mouse pointer and mouse down, do something, and then wait until the mouse button is not down, and that will represent the entire click cycle.